Right, we're going to work through some of the practice questions together here. So practice question 31, we have a 250 gram sample of water that contains this 8.30 times 10 to the negative 3 grams of lead. So this would be our solute, and this would be our main solution, right? Okay, so we have to calculate the concentration of lead in the sample in parts per million. All right, so since we're finding parts per million directly, let's just use the formula that's in our data booklet on page 10. So that's parts per million is equal to the mass or volume of the solute. In this case, it's mass of solute all over the mass of the solution, and then multiply by 1,000,000. All right, so our mass of solute is the lead. So that's 8.30 times 10 to the negative 3 grams, divided by the mass of the solution, which is 250 grams, all multiplied by 1,000,000. So we're going to take the top number, divide by the bottom number, and then multiply by 1,000,000. I missed a 0 there. And we're going to get 33.2. And this is parts per million, are the units for that one. Now the part B, you would have to refer to the table in your textbook. I don't have that right in front of me right now, but according to that table, it is actually not safe to drink because it exceeds the maximum amount of 0.01 parts per million. Okay, so that was question 31. Let's look at question 32. So 32, Canadian law prevents the sale of fish for consumption containing more than 2 parts per million of PCBs. A 227 gram sample of fish is tested and found to contain the maximum allowable concentration of PCBs. Okay, so it contains this maximum here. Determine the mass of PCBs in this sample. All right, so we are actually given parts per million, ppm. So instead of using that formula from down below, I'm going to use this formula we have set up already that's nice and easy to use for cross multiplying. I would write these formulas somewhere in your learning guide for sure. You'll want these for your quizzes and mini assignments. So we're going to write this formula out, parts per million over 1,000,000. Is equal to mass of solute divided by mass of solution. All right, let's throw our numbers in. So we have parts per million is 2.00 parts per million all over 1,000,000 equals the mass of the solute, which is what we're trying to find. So I'm just going to go mass of solute all over the mass of the solution, or the sample, the entire amount. So it's 227 grams of fish in this case. Okay, so we're going to do some cross multiplying. Remember, I'm just going to show this in a different color. So we're going to take these two numbers and multiply and let them equal these two numbers. So we're going to go 2.00 parts per million times 227 grams, and that is going to equal 1,000,000 and times the mass of solute. To get our million away from our mass of solute, we want to isolate our mass of solute. We're going to divide by 1,000,000, right? 1,000,000 divided by 1,000,000 is just 1, and then whatever we do to one side, we better do to the other side. There we go. So our mass of the solute is equal to this big number. So we're going to go 2 times 227. So 2 times 227, and then divide by 1,000,000. 2, 3, 1, 2, 3. So on my calculator, I get 4 times 10 to the negative 4. Whoops, I'm sorry. 4.54 times 10 to the negative 4. Or you can write that by moving the decimal over 4 places. 1, 2, 3, 4. So it's going to be 0.000454. And our units are going to have to be in grams because that was what our fish was in. So the same units have to be on top as well. So this is in grams. So either of those numbers is acceptable. Yeah, so there you go. There's your answer. Alrighty, and we'll just check our significant digits. There's 3 digits in the both numbers in our calculation, so 3 digits here. Remember, leading zeros don't count, so that's good. Okay, question number 33. Okay, it is considered unsafe to have more than 50 parts per million of arsenic in drinking water. If you have a bottle of water containing 250 grams of water with this level of arsenic, what mass of arsenic would you ingest? All right, so this is actually just like the last question. Same kind of setup, but totally. We are given parts per million and we're given the solution value and we're looking for the arsenic or the solute. So let's set it up exactly the same way. Parts per million over 1 million equals mass of solute over mass of solution. And our parts per million is 50.0 parts per million. And we're going to divide that by 1,000,000. And we're going to equal the mass of the solute, which is what we're trying to find. We'll just leave that as M. And then the mass of solution is 250 grams. Okay, again, we're doing some cross multiplying here. So we're going to do 50.0 parts per million times 250 grams. And that's going to be equal to 1,000,000 M mass. Okay, divide both sides by 1,000,000. 1, 2, 3. Millions cancel out. Divide the other side by 1,000,000. I don't know how many zeros I got there. All right, so 50 times 250 divided by 1,000,000 gives us 1.25 times 10 to the negative 2, and it's in grams again. Or we can change this to a decimal place, so it's 0.0125 grams. And that's what our mass of solute is equal to. And we're done.